Okay, so in section 11.2, we're going to talk about the quadratic formula. Now, coming to this section, again, we already know about two ways of solving quadratic equations. That would be factoring, and the other method in section 11.1 we looked at was completing the square method. So this would be yet another method, call it a third method of solving quadratic equations. So again, what we have here is a quadratic equation that is in the form ax squared plus bx plus c equals 0. And we want to solve this equation. Again, a, b, c's are numbers and the variable, the unknown, is x. Now, in order to show you how the quadratic formula is derived, since that's all we're doing in the section, so let me go through actually the derivation of the formula that leads to the quadratic formula, the work that leads to it. So here's how we're going to do this. We're going to actually solve this equation by completing the square method. So I went ahead and moved c to the other side. Now remember, the coefficient on x squared has to be a 1, so I need to divide everything throughout by a. And when I do, I get ax squared divided by, this is a, and then plus bx divided by a again, and equals to negative c divided by a. So again, I divided everything by a here. Now, next step, I can write this as x squared plus b over ax equals negative c over a. Now, completing the square method, if you recall what I'm going to do next to complete this square, we're going to add something to both sides, and that something is going to be 1/2 of the coefficient on x, which is b over a. That's b over a, and then we're going to square it, and that's what gets added to both sides. So this is going to give me b squared over 4a squared. Okay, and the next step is to add that to both sides. So here we go. I'm going to get x squared plus b over ax plus b squared over 4a squared negative c over a. Okay, actually equals negative c over a, and then I'm going to add b squared over 4a squared to both sides. Okay, now because of the way we added this b squared over 4a squared to both sides by completing the square, we know that on the left side now we have a perfect square trinomial. So the binomial form of this is going to be x plus 1/2 b over a, which is going to be b over 2a quantity squared. And on the right side, we can combine these two fractions. Now, negative c divided by a, I'm going to need to take common denominators here. So I'm just going to build the denominator of this one by multiplying 4a and multiply 4a on top. So we build a fraction to the LCD, which is 4a squared plus b squared over 4a squared. And this will make it on this side. I'm going to have a denominator 4a squared, and that's b squared negative 4ac. I simply swap the places for these two. Okay. And let me see something. View. I'm going to actually put some lines here for you to be able to see this better, and I can keep my writing in line as well, so it looks a little better. Okay. Now, so our next step is to use square root property. We're going to take the square root of both sides. Okay. And taking the square root of both sides, I get x plus b over 2a. That's taking the square root of what's up here, and then taking the square root of, there we go, that's just square root of this. And then we're going to take the square root of the right side. Taking the square root of the right side makes it square root of b squared minus 4ac divided by 4a squared. And if you recall, anytime we take the square root, we're going to have a plus or minus. So this is going to be plus minus that. So let me maybe do this. Let me maybe just erase this a little bit. So there, squeeze that equal sign in there. Now I can put my plus minus better. There we go. So that's what we have. Now, our next step is to take the square root, and I'm going to move this fraction to the other side. Okay? So let's see what's going to happen. When we do that, so we're going to get x is equal to negative b over 2a. That's the fraction moved to the other side. And then I have plus or minus. Now, in here, when we take square root of 4a squared, because a can be any real number, right? So if you recall, when we take square root of a squared, the answer is going to be absolute value of a, if a is any real, right? So here, let me write that a, that number a is real. That means it can be positive or negative. And by definition of principal roots, remember the square root simple means we want the positive or principal root of that. Now, square root of a itself, if you remember, square root of a can be written this way. We can write it as just a if a is positive or 0, and negative of a if a is negative. Okay, now right in here, the reason I need to explain this, because we are about to take the square root of the denominator right in here, a squared. So when I do that, I'm going to go ahead and write it in this way. I'm going to put b squared minus 4ac divided by, that would be 2, that's square root of 4, and then I'm going to go absolute value of a, okay, because a can be any real number. Now, if you look at your book, by the way, in the book that we use, they assume a is positive, and in this stage, at this step right in here, they just put a. Because if it's positive, you don't need absolute value. There you are, right in here. That's what we said. Now, the way we're going to actually get out of the absolute value is this. Regardless of whether I use a positive a or negative a here, because the way this plus minus works right in here in front. So if a is positive, that's going to be positive, and this is going to be negative, right? The plus minus. And if a is negative, right down here, if a is negative, the effect on the whole fraction here is to change the positive up here to a negative, and the negative down here to positive. In other words, we're going to get into a situation like this. So I'm going to have, let's say, plus or minus something like 2, and this is going to become negative positive 2. That's if a is negative down here. Okay. Now, as far as we are concerned, these are two numbers, negative 2, 2, and so are these, negative 2, 2. So they're really the same two numbers in the set. Okay. So as a consequence, again, what I'm about to do, I'm allowed because of the plus minus, the way the plus minus incorporates with the absolute value. So all said and done, I'm going to write this as x negative b plus or minus square root of b squared minus 4ac, and then all of that divided by 2a, and that is what the quadratic formula is. So notice we have the solution to x. So in order to use the quadratic formula, all we have to do is to simply identify the ABCs in the equation and just make sure that we mind the order of operations, and everything's going to work out nice. Okay, so hopefully you follow this. Again, this is just a derivation of the formula. You're going to be the end user of just the formula, but I thought it would be nice to see where the formula comes from. So with that, your homework, by the way, let me write down that for your homework, you're doing exercises, I believe numbers 21 and 25. 21 and 25. I just have you do a couple of these. Again, I think a couple would be enough for you to get a feel for how this is done. So let's take a look at actually maybe start with number 8, and then I work my way towards 21 and 25. Now let me show you the page of the book here where the exercises are, and this exercise is on page 713. So let me go to that page number, and I'm just going to type in 1-3, enter. And once this page loads, you're going to see the exercises. So in section 11.2 is where we are again. I'm going to scroll down and right in here. So you're doing again exercise number 21, this one, and you're doing exercise number 25, the bottom. These are the two that you're doing. So I'm going to do exercise number 8 to kind of get started. Then I will do number 22, and then I'll do number 26 for you. Okay, one's like the homework problems. So let's do this. I'm gonna go now back to my note, and here we go. So in exercise number 8, there we go, get my pen going. So in number 8, now the equation here is 3x squared negative 7x plus 2 equals 0. Okay, so let's identify the ABCs. The A is a number that attaches to x squared, right? So this is going to be the A. A is 3. B is the number, the coefficient on the middle term, the x term, and that is simply negative 7. And C is going to be the constant. So if it's positive, it's then positive. If it's negative, we write negative. So those are now the ABCs. We got the ABCs. Now I'm just going to go to our formula and plug in these ABCs into this formula. Okay, so let's see how it's going to turn out. That's going to become x is equal to negative b, that's negative of negative 7. That's what this number is, negative 7, plus or minus the square root of b squared, that would be negative 7 squared, minus 4a. A is 3 and C is 2. And there you have it. All of that is going to be divided by 2a. That would be 2 times 3. And there we have it. So next step. In the numerator, negative of negative 7 is 7, plus or minus. Then we have the square root. Negative 7 squared is 49. And 2 by 3 by 4. 4 by 3, 12 times 2, 24. All of that divided by 6. And then I can do the radicand now. What's under the radical sign? 49 minus 24, that would be 25. So that's square root of 25 divided by 6. And that's going to be 7 plus or minus. Square root of 25 is 5. Notice 25 is perfect square. This number, remember, we call this a perfect square. This number is perfect square. That means the answer is going to be a number times itself. It's going to be a whole number. Perfect square. So the square root of that is 5. And from this, we're going to get 2 solutions. So one solution is going to be 7 plus 5 over 6. And the other solution, call this x1, x2, 2 different solutions. It's going to be 7 minus 5 over 6. Now 7 plus 5, 12, 6, that would be 2. And 7 minus 5, 2, 6, which reduces to 1/3. So the solutions are 1/3, comma, 2. And there we have solved the equation by quadratic formula. So hopefully you follow that. Let's take a look at another one. This time I'm going to do number 22. Remember, you're doing number 21. So in exercise number 22, this is going to be p squared plus p plus 4 equals 0. So now the variable changed from x to p, but remember these are dummy variables. That means they can be a, b, c's, x, y, z's, whatever. So let me put now the numbers because we need a, b, c. So here's 1 in front of p squared. you can think of a 1 in front of P also. So that would identify my A and B. So A is 1, B is 1, and C is 4. So going to the formula, instead of X, now we change the variable to P, and it's going to be, here's 2 times A is 1, and then negative of B is 1 also, plus or minus the square root of B squared, that's 1 squared, minus 4, A is 1, and C is 4. And there you go. So it's going to be negative 1 plus or minus the radicand. 1 squared is 1, minus 16. That makes it square root of negative 15. All of that divided by 2. And remember the negative, the radicand negative, we can use the I notation. So the solution to the variable is going to be negative 1 plus or minus root 15. And then I'm just going to put I here. Remember, I replaces the square root of negative 1 divided by 2. And just to remind, I is the square root of negative 1, defined to be that. Okay, and there we have it. So we have two, we got two complex solutions. Now I'm just going to rewrite P in the form negative 1/2 plus or minus root 15 I, just to maintain the form of a complex number. Remember, it was the A plus BI form, so I'm trying to conform to that. And there you go. We got the two solutions. So in this case, we have two imaginary solutions. Okay, two imaginary solutions for this one. And that was exercise number 22, right up here. Our next exercise, we're going to take a look at exercise number 26. That would be the last one for this section. We're done with this section. In exercise number 26, here we have 15t squared plus 7t equals 2. Okay, so before we can identify the ABC, we got to make sure that 0 on this side, in that here we have this must be 0. That's what it ought to be. So I'm going to subtract 2 from both sides, or simply move 2 to the other side. So it's going to be negative 2 equals 0. And now again, we can identify our ABCs. So A is 15, B is 7, and C is negative 2. And then from this, I'm going to solve the equation for t, and the solution is going to be 2a in the denominator, that would be 2 by 15, negative b in the numerator, plus or minus the square root of b squared, that's 7 squared, minus 4a, a is 15, and then c, negative 2. And be careful, notice how I extend this fraction line. The fraction line has to cover the entire numerator, okay, not just portion of it. So this is going to be negative 7 plus or minus. Now, let's work the radicand another step. 7 squared, that's 49. We got double negative here, right? We have a negative 2 here and a negative 4 here. That makes it positive. Okay, so that's going to be a positive. 2 times 15 is 30. 30 times 4 is 120. Okay, or 4 times 15 is 60. 60 by 2 is 120. However you do that, divided by 30. And now t is equal. Let's combine in the radicand. 120 and 49 makes square root of 169. Works out nicely because 169 is perfect squared. So square root of 169 is 13. So this is going to be negative 7 plus or minus 13 divided by 30. And again, two solutions emerge out of this work. T1, the first one, negative 7 plus 13 divided by 30. Negative 7 plus 13, that would be 6. So 6 over 30, which reduces to 1/5. And the other one, T2, is going to be negative 7 minus 13 divided by 30. That's negative 20 over 30. and that's going to be reduced to negative 2/3, and that is T2. So the solution to this quadratic equation are 1/5 and negative 2/3. There's our solution set. In this case, we have two rational solutions. Now the reason I write it, you don't need to do this. The reason I do is because in the next section, we're going to be taking a look at solution types, and that's when this will come in handy in that section.